hour. Today's topics are going to be systems of linear equations, which covers chapter 6, 6.1, 6.2, and 6.3. Okay, these are the topics that I'm going to cover. Systems of two linear equations and two variables. Determine whether an order pair is a solution to the systems of equations. Graphing, solving by graphing, substitution, elimination. And then how do you apply those topics in the real world? And then we're going to be doing larger systems of equations by solving by the elimination method, matrix method, and then how do they apply also to the real world? Okay, so let's begin with determine whether the given order list of numbers is a solution of the system of equations. Okay, how do we begin this? Here, what we're going to do, we're trying to find out if the point -1, 3 is a solution to these two systems, to the linear of to the two systems of linear equations. So the objective is to plug in -1 for x and 3 for y. Okay. So for example, let's call this equation 1 and equation 2. So we're going to plug in equation 1, right? So we're going to plug in -1 for x and 3 for y. I like to put like parentheses, guys, just to show that this is a value that we're going to plug in, which is -1 for x and 3 for y. Then after we simplify the left side of the equation, it's going to give us -2 plus 3 equals 1. So this is true, right? Because 1 equals 1. But for the for the order pair to be a solution, it's going to be true for, we plug it in, for both equations. So now let's go to number 2. And again, the same manner, I'm going to plug in the -1 for x and 3 for y. Okay, after I simplify the left side of the equation, it should give us 3 plus 6. So 3 plus 6 equals 9. So 9 equals 9. That means that this point, -1, 3, is a solution to the linear to the system of linear equations. Okay, so it makes both the equation true. So then the order pair is a solution. Now let's do the same apply the same concept to number 2. But now we have the x value is 2 and the y value is -0.5. So again, we're going to plug in 2 for x and -0.5 for y. So again, equation 1, equation 2. So let's repeat the process once again. So I'm going to plug in 2 for x and -0.5 for y. This gives us a 1 minus 4 equals -3. So this makes it true. So once it makes it true, that means that we can proceed to plug in it to equation number 2. If this wasn't true, then we will stop there, and then we will just say this is not a solution. The order pair 2, -5 is not a solution. Okay, but since this is true, we'll continue to plug it into equation number 2. And again, we plug in 2 for x and -0.5 for y. This will give us -0.5 equals to -5, which is not true, right? So that means that the order pair 2 -0.5 does not make both equations true. Then the order pair is not a solution. So this one's yes, and this one's no. Okay, that's how you can check your answers when you solve them by either by graphing, by substitution, or by the elimination method. Okay. So now let's see how the graphs look like when it's one solution. You see, guys, when it's one solution, it means that it crosses at exactly 1 point. So for those two systems, the solution will be 3, 2, right? Because that's where it crosses. This means it's going to be infinite solutions, which means it's a line on top of another line. That's what that means. And the one here on figure C, it means that the lines will never intersect. So this one will be no solution on figure 6.1C. The lines are parallel, they will never intersect. Okay, now, so when we're solving by substitution or the elimination method, this is what you will get. Okay, something like this. When you have one solution, it means after you solve it by substitution or by the addition method, you're going to get something like x equals to a or y equals b, which means x will equal to a number. Okay, but this is the notation for math. Okay, and then we have to let a and b be real numbers, which means x is going to be a number and y is going to be a number. That means one solution. You see, for example, here it was 3 and 2. Okay, now, and this is called, for example, x equals to 3 and y equals to -2, an example. This one will be something like this, right? You can have a equals to a, you're not going to have no more x's or no more y's, but you can have two numbers equal to each other. That means it's going to be infinite solutions. Like something like 3 equals 3 or 0 equals 0. There's no x or y. Okay? Now the one on C, no solution will be something like a equals to b. Let a and b be real numbers, right? But a equals to b, you see these are not equal because 3 equals 4, right? That's not true. So then this is an example of no solution. So there's no x or y. So right now, as I go over the examples, you'll be able to know what I'm talking about. I know right now it might be a little bit complicated what I'm trying to say, but right now I'm going to remind you, going back to the figure 6.1. Okay, I'm going to say this is like 6.1a, 6.1b, or 6.1c. Okay, so let's continue. This is called consistent. Okay, this is also, I believe, there are some books that actually want you to say if it's consistent and independent. If you have one solution, it's going to be consistent, independent system. If you have infinite solutions, it's going to be consistent but dependent, which means the y depends on the x, and this will be inconsistent because there's no answer there. Okay, now this is called the graphing method. Okay, to graph, I believe you should know how to graph by now. Okay, but if not, let's do like a little quick review here. Equation 1, right? So we have to graph both equations and then see where they intersect. Equation 1, right, is y equals to 3x minus 6. This is graphing in the form of y equals to mx plus b. The m is my slope, right? So it's going to be 3 over 1. And my b is my y-intercept, which is negative 6, right? So the y-intercept will be 0 and -6, and this is my starting point. Okay, my starting point is 0 and -6. Then I'm going to go up 3, 1, 2, 3, and 1 across. And that's my slope that I got it from here, right? 3 up and 1 to the right. So again, 1, 2, 3, 1 across, so it's going to be about right there. And all we do is draw the lines between the 2 points. Now we're going to graph equation 2. So equation 2, it has to be the y equals to mx plus b. Okay, that way we can see what the slope is and what the b is, which is the y-intercept. So we have to isolate the y. So first we add 5x to both sides. So we get -2y equals to 5x minus 10, right? We just added 5x to both sides of the equal sign. Then we divide by -2. So then this is my result. So this is like my m, and that's my b. This is my slope. My slope is -5 over 2, and my b is 5, which is the y-intercept will be 0, 5, and this is my starting point. So we start at 0, 5, right? This is my starting point, the b. And then we're going to go down 5, down 5, and 2 to the right. So we're going to start here at 0, 5. We're going to go down 5, 1, 2, 3, 4, 5, and 2 across. 1, 2. And then we connect the 2 points. So then that means that this is my solution, which is, right? So where the points intersect is my solution, which is going to be 2, 0. That's my solution to the system. Okay, now I'm going to repeat the process, this very same equation, but we're going to solve it by substitution and also by the addition method. Okay. So again, let's do the very same equations, system of equations, but let's do it by substitution. Okay, by substitution, we have to try to isolate one of the variables. In this case, the y is already by itself, right? It's already isolated. So I'm going to use, let's just here, since y is isolated in equation 1, we're going to substitute 3x minus 6 for y in equation 2. So in other words, I'm going to plug 3x minus 6 right here for the y. Again, it says substitute 3x minus 6, and I put it in different colors so you know what I'm talking about, right? So it's going to be 3x minus 6, right? We plug it in for y. And then here we do the distributive property. So this becomes negative 5x minus 6x plus 12 equals negative 10. So we combine the like terms. This will give us negative 11x plus 12 equals negative 10. Now we're going to subtract 12 to both sides, right? Because we're trying to solve for x. So negative 12 minus 10 will give us negative 22. Then we divide by negative 11. So x equals 2, right? So when we get the x value, we can go back. We need to find the y value, so we can go back to equation 1 or equation 2, right? To plug in the value for x to solve for y. And it's easier to plug it in for equation 1. Why? Because the y is already isolated. So what we do, we're going to plug in the 2 over here for the x's, and we got the value for y. Okay. So x is 2. So 3 times 2 is 6. 6 minus 6 is 0. You see, guys, so x is 2 and y is 0. So this is my solution, 2, 0. You see the same thing that as I got on the graphing part. And a student might be thinking, well, why do you show us the same one in different ways? Because if the instructor is specific to solve it by graphing, you have to do it by graphing. If they want you to do it by substitution, well, you have to do it by substitution, which is this method. And the next method that I'm going to show you is called the elimination method. So if they want you to do it by the elimination method, you have to do it that way. But if they don't say how to solve it, you can use either one of the forms that I showed you, and also I need to show you one more. Okay, so with that said and done, again, this is consistent and dependent because we have one solution. Now let's do the very same one, but let's solve it by using the elimination method. Okay. So for the elimination method, we have to put it. We have to put both equations in the form of ax plus by equals c. For example, equation 2 is already in this form, right? You have the x and the y equals to a constant. But equation 1, we need to place it in this form. Okay. So let's do it then. We need to rewrite equation 1 in proper form. So here we're going to subtract 3x to both sides. So it gives us negative 3x plus y equals negative 6. So now it's already in proper form. You see, this is equation 1, which we just put it in proper form, and this is equation 2. So here, guys, how you do it by the elimination method, you want to cancel the x's for the y's. Whatever is easier for you guys. You see, in my opinion, you see, like I said here, need to eliminate the x's or y's, whatever is easier for you. In my opinion, I'm going to eliminate the y's. Why? Because if I multiply this whole equation by positive 2, you see 2 times y will give me 2y, and when I add them, they'll cancel. It'll give me a 0. But I have to use legal math concepts. I need to multiply 2 times both sides of the equation, or multiply 2 times every term. So 2 times negative 3x will give us negative 6x. 2 times y will give us positive 2y. And 2 times negative 6 will give us negative 12. And equation 2, we just bring it down how it was. You see now, you see this 2y minus 2y will give me 0, but we have to add the x's, which will give me negative 11x. We have to add the constants, which will give me negative 22. Then we divide both sides by negative 11, and we get 2. So this is my x value. And again, once you get to this step, the other ones repeat, right? Because now we have to solve for y. So we can plug it into equation 1 or equation 2. It doesn't matter. Whatever is easier. Okay, so here, again, I'm going to plug it into equation 1, right, because it's easier. So I'm going to plug in the 2 there. So it's the same thing as the other one, as by substitution, right? The second part, so we get y equals 0. So then this is my solution, 2, 0. And again, we got the same thing for solving by graphing, by substitution, or by the elimination method. Now I'm going to do this very same process again, but I'm gonna be solving. I'm gonna try to eliminate the x's instead of the y's, just so you see it's a little bit more work. Okay. So let me do it again. Again, the same thing, but now I'm gonna get rid of the x's. Right. We repeat the process as before. Okay, right, so right here. So just so you see, right, and I mean in the previous slide, we just multiplied the first, the equation 1 by 2, right? That way they'll cancel. But let's say that you didn't know that. Okay, so then I need to multiply equation 1 by 5 by negative 5 and equation 2 by 3. Why? Because negative 5 times negative 3 will give us positive 15. And 3 times negative 5 will give us negative 15. That way they'll cancel. You see in here, I multiply negative 5 times every term on equation 1, which gave us 15x minus 5y equals to 30. And we do the same thing with equation 2. We multiply everything by 3, every term by 3. So 3 times negative 5 will give us negative 15x. 3 times negative 2y will give us negative 6y. And 3 times negative 10 will give us negative 30. Right? So then you see here the x's cancel because 15x minus 15x will give me 0. But we add the y's. So then we divide both sides by negative 11. So y equals 0. Now I need to go back to either equation, right, and plug in 0 for y to solve for x. And here, guys, I'm going to go to equation 2, I believe. You see, I'm going to go to equation 2. So y is 0, so I'm going to plug in the 0 there. So that'll give us negative 5x equals to negative 10. Then we divide both sides by negative 5. And the answer is 2. You see, guys, so we got the same solution. It didn't matter how we solved it. So the solution is 2, 0. Okay. Okay, now, you guys remember, again, going back to the figures, figure 6, I think 6.1, it was A, B, and C about the graphing. They show you a picture. This is when you have one solution, right? Where the graph crosses at exactly 1 point. Now, this will be an example when you have infinite solutions. When you have, I believe it was A equals A, remember that? And I tell you that I will let you know later how do you know it's going to be infinite solutions? Here's an example. So here, guys, I'm going to get rid of the x's. So multiply row 1 by negative 2. Right, so give us negative 6x plus 4y equals to negative 8. And then equation 2, we just bring it over. You see, if we subtract, we do the addition or the elimination method, it's going to give us 0 equals 0, right? And this is true, right? 0 equals 0. And remember when I mentioned there's no x's, no y's? That means it's going to be infinite solutions, which means it's going to be consistent but dependent system. This is an example from figure 6.1. This is an example of figure B, when the line was on top of the line. Now, this is an example of the last one where there was no solution. Okay, but remember it was like A equals B, right? Because A does not equal B, right? And it was like 3 equals to 4, which is not true. That way it's going to be no solution. Okay, again, I multiply the first row by negative 3. So it gives us negative 6x minus 15y. And negative 3 times A will give us negative 24. And equation 2, we just bring it over. So here's going to give us a 0 equals to negative 6, right? Which is not true. That means it's going to be no solution, right? And that means that it's going to be an inconsistent system. That's what this system is called. Okay. Okay. Now I gave you an example of each one. Sorry that I cannot give you more examples because I only have an hour and I'm trying to cover as much material as possible. But you can always come back to these to help you how to solve the problems that are assigned for your homework. Now, let's see how this type of problem is used like in real life. Okay, this is a word problem. Okay, it states a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay, so here's my solution. We need to find two equations. Okay, like I tell my students, right? We're going to do seats with seats, right? Seats with seats and money with money. What does that mean? Seats with seats and money with money. So for example, I'm gonna let X equals to the adult seeds and Y equals to children seeds, right? So X means adults and Y means children. So it's gonna be seeds, right? Adult seeds plus children seeds equals the total number of seeds, which will be 200. So this is my equation. X plus Y equals to 200. Now comes money with money. So here, if 8, right, means the adults, right? Adult tickets are $8, and the adults is represented by X, so then it's going to be 8X. If the children's tickets are $5 and children's seats is a value for Y, then it's going to be 5Y. And what's the total income? $14.35. So it's going to be 8X plus 5Y equals to $14.35. You see, so I found my two equations. Now you can solve it by graphing, which I don't recommend because it's going to be hard to graph it with real big values. You can do it by substitution, which is also good, but in my opinion, it's already in the form AX plus BY equals C. I mean, both equations. So I'm going to solve it by the elimination method. In my opinion, that's much easier. But that's my opinion, right? Some students like to use the substitution method. And like I said, here it doesn't say how to solve it, right? It just gives you the problem, so you have to find what you're looking for or solve it, right? So I like to do it by the elimination method. So I'm going to get rid of I believe the excess. So this one, I'm going to multiply it by -8. Why? Because -8 times x will give me -8x. Then when I add it to 8x, it'll be 0x. Okay, so -8 times x, -8x, -8 times y, -8y, and -8 times 200 will give me -1600. And equation 2, we just bring it over. Right now, we add them, right? So the x's are eliminated, and we're left with -3y equals to -165. So then we divide both sides by -3, so we get 55. So y equals 55, right? So now I can go back to either equation 1 or 2, plug in the value for y, and solve for x. In my opinion, again, it's easier to go to equation 1. Okay. Remember that y is 5, so I'm going to plug it in here, the 55. So y is 55, so it's going to be x plus 55, right? Because y is 55 equals to 200. So my next step is we subtract 55 from both sides, which will give us 145. So my x is 145, my y is 55, right? So they want to find out how many adults and children were in the audience. The x represents adults, so there's going to be 185 adults and 55 children were in the audience. That's how you solve these type of problems, by using solving systems of linear equations. Okay. Now, this is larger system of equations. This is something like, I believe, from 6.2. This is going to be something like, right now you're going to have 3 variables, x, y, and z. Okay, so we have to solve it. So, like I told my students, we have to come up with a plan. I mean, I was actually come up with a plan so I can show my students. Because at times, students tell me, hey, Mr. Isasi, so what are the steps? At times, the steps is that you need to know what you're doing, right? But in some cases, I come up with a plan. That way, the students can follow my plan. And this is my plan, okay? It's going to be equation 1, equation 2, equation 3. So at first, I want to have an x on the first equation, right? But with a coefficient of 1. So you can do it at the beginning. You can switch rows 1 and equation 1 and 2. You see, rearrange if possible, coefficient of 1 on the x being equation 1. So this one, I'm going to put it as equation 1, and 2x minus 2y plus z equals 3. I'm going to put it as equation 2. So that's what I did. And right now, you're going to see why it's easier, okay? So then, here's what's the plan. Here's my plan. I'm going to get equation 1 and 2, and I'm going to get rid of the x's. I'm going to get equation 1 and 2 and 1 and 3, and eliminate the x variable. Then, after you eliminate the x's in 1 and 2, and also in 1 and 3, we're going to get like a new equation 2. And here at the bottom, we're going to get a new equation 3. So then we get the new equation 2 and the new equation 3, right? And we're going to get rid of the y's. Eliminate the y's. And then we're going to get something like z equals to a number. After we do this, we're going to get z equals to a number or to c, and c is a real number. All this means is that z will have a value. I remember, guys, when I was a student, that all this seemed real complicated to me. That I understand why you have to put that there. It's because when it comes to math, you have to use the correct terms and the correct terminology. And when I was a student, I didn't really like all this, so I kind of disregarded it. But then when I was going for my master's and also at UTEP, I found out that the way I did some of the things that at the PCC, I didn't do it right because I didn't like to learn about the vocabulary and the terminology. I was a type of student that would say, "Show me an example, and I can follow." And sure enough, all that got cut up to me. So that's why at times I like to share what I went through with my students, so that way they know how important it is to understand the terminology and also the concept. That's why you have to know that this is legal terms. That let C be a real number, right? So in other words, it's going to be z equals to a number here. So then that's my plan. Okay. After all the steps, the equation should look like this. The system. And after it looks like that, we back substitute. Okay, so let's put it to action. Here we go. So let's get equation 1 and equation 2, right? So I'm going to get rid of the x's. You see, it's always good to have equation 1 with a coefficient of 1 because this way I can use that equation to eliminate the x's. So then this has to be a -2, right? Because -2 times x will give me -2x. Then when I add it to 2x, they'll be eliminated. But I have to multiply -2 times every term. So -2 times x will give me -2x. -2 times -3y will give me positive 6y. And -2 times positive 2z will give me -4z. And -2 times 0 will give me 0. And equation 2, we just bring it over. So we add them. You see, so the x's were eliminated. So this is like the new equation 2. Okay. Now I repeat the process with equations 1 and 3. And again, I want to eliminate the x's. So then I'm going to multiply equation 1 by -3. Because this way it guarantees that the x's will be eliminated. Okay, and after I distribute, I get -3x plus 9y minus 6z equals to 0. Equation 2, we just bring it over. Equation 3. And then after we add them, right, the x's are eliminated. So this is my new equation 3. Now what's my next step of the plan? I'm going to get equation 2 and equation 3, right? And then I'm going to get rid of the y's. So here, at times, the instructors might say something like this. Well, what's the least common multiple between 4 and 10, which is 20, right? 20. If I use 20, I can eliminate both by multiplying by 5 and by -2. But at times, students, they don't know about the least common multiple. So I tell them, well, you don't have to do it that way, right? So what's easier is just multiply this one by -4 and that one by 10, or vice versa, -10 and 4. Because this way it guarantees that they're gonna be eliminated, the y's. So this will multiply by -10. If you notice, the number that's here, I multiply the first equation by that, and the number that's equation 1, the coefficient, I multiply the second equation by 4. But since they're both positive here at the beginning, I have to multiply 1 by a negative. That way, it'll guarantee that they'll be eliminated. So after I multiply -10 times every term on equation 2, it gives me -40y plus 30z equals to -30. And again, I multiply -10 times 4y, -10 times -3z, and -10 times 3, and this was my result. In a similar fashion, I'm going to multiply 4 times 10 will give me 40y, 4 times -7z will give me -28z, and 4 times n will give me 28. So after I do the operation, we get 2z equals to -2. We divide both sides by 2, and it gives me z equals to -1. Remember, guys, it was z equals to a number. If z equals to c, well, there's my c. And -1 is a real number. So now, you see, I get equation 1, which is that one there. Then for equation 2, I can use either the new 2 or the new 3. I like to use the new equation 2. And then for the last equation, it's going to be z equals to -1. Then I'm going to back substitute. right? So I already know what the value for z is. So now I'm going to go to equation 2. With equation 2, and I'm going to plug in -1 for z and solve for y. Z is -1, so that gives us for y plus 3 equals 3. We subtract 3 to both sides. So 4 equals 0, so we divide both sides by 4. So we got that y equals to 0, right? So I already have my value for z, my value for y. Now I'm going to go back to number 1, and I'm going to plug in the values 0 for y and -1 for z, right? My y is 0, and my z is -1. And I simplify the left side of the equal sign, so we get x minus 2 equals 0. So we add 2 to both sides. So now we have my x, my y, and my z. So this is my answer: 2, 0, -1. Okay. Are you guys okay up to this point? Just put in the chat if you're okay or not, or if you have any questions. Perhaps you can let Patricia know, and then she'll tell me what kind of questions that you guys might have. Okay, so let's continue. Okay, now, AA students, this perhaps is one of the most difficult topics for 1324, and even for 1314. A lot of students have a hard time with this method here. And I like to, but this method, I kind of modified it that way students can actually follow. So I start with the objective, and I start. Just follow my part. This this video, or if you want the PowerPoint, that's in it too. You just follow it, and you should be okay. Okay. But this is my objective. We have linear systems of equations. We have to transform it to augmented matrix. And then it's going to be RREF, which is matrix solved in the reduced row echelon form. And also, this method can be done in the calculator, but it has to be a TI-83, TI-84 calculator. Okay, and I believe the tutors can help you how to do that, but it's always good to know it. Well, it's good to know it by hand, and you should know it by hand. At the time, some instructors give you guys one of these ones, and you have to do it by hand. And this system, the Gaussian elimination method, you need to know it for 1325 because you're going to do something similar, okay, for chapter 7. Okay, now, so what's the objective? Okay, so this is called the linear systems of equations. So for augmenting matrix, we only get the coefficients. You see, we're going to get 1, -3, 2, 0 for row 1, 2, -2, 1, 3 for row 2, and 3, 1, -1, 7 for row 3. When it comes to matrix, this is like row 1, row 2, and row 3. Okay? Now, you wanted to make it look like this, right? Which means this is my x, y, and z. That means that x equals to 2, y equals to 0, and z equals to -1. I'm going to solve the same one that I did earlier, just so you see that you can do it this way, but this way is a little bit more challenging. Okay, now, so what's the objective? Okay, how are we going to do it? Okay, here's my plan. I call it the 3-step plan. Okay, so the plan is that, okay, I like to use right. This is like math terms. All these are going to be like A, B, C, D, right? So all these means are the coefficients from the system, right? But you have to say what they are. Let all letters be real numbers. This is called augmented matrix, right? So then we have to put it in reduced row echelon form, so it has to look like this right here, right? After all these becomes 1, we have 1 equals to whatever x equals to whatever the value is there, y equals to whatever the value is there, and z equals to whatever the value is there for z. That's the objective. And if you notice, I have everything color coded. You see, this is step 1, step 2 is in green, and step 3 is in red. So for step 1, I need to make the E and the I be zeros. You see, row 1, row 2, row 3. So step 1, I need to make that a 0 and that a 0. That's why I put arrows there, because row 2's got to change and row 3's got to change. These two here. So after I do the step 1, right, there's zeros, right? That completes step 1 there. Then step 2 in green, the B must be a 0 and the Q must also be a 0. Right, so you see that's going to change, which is row 1, and row 3 is going to change. So after I execute the proper steps, that's what we get. So then step 3, the part that, like for example here in row 1, this is a Z value, and the Z value on modes 1 and 2, on rows 1 and 2, these have to be zeros here. And I'll always be using like W here. Here for step 1, I'm going to use row 1. For step 2, I'm going to use row 2. And for step 3, I'm going to use row 3, the W there. And you simplify it possible as you do it step. This guarantees that you're only going to have three matrix, the original augmented matrix. After that, you're going to have 3 matrix, and that's it. At the most 4. But most of the time, you're only going to have 3. The way the book shows you, they have about 8, 9, 10 different matrices. How other instructors also explain it, they also have about 9, 10, 12 matrices, something like that. Okay, and again, this is my modified version that I came up with of the Gauss-Jordan elimination method. So anyway, that's step 3. Okay, now I also do it for students to understand, right? Because at times students they don't like to use letters, right? Because that's the way it was when I was in college, EPC. So that's why I put number signs for the students that actually don't understand it with letters. Okay, so you see the same thing again, but instead of letters, I use number signs. You see, I'm going to go kind of quick. Same thing again, step 1, then step 2, then step 3. Again, same thing, but instead of letters, I use just number signs. Okay, let me go back again to the previous slide. You see, so again, this will be x equals to whatever the number is there, y equals to whatever the number is there, and z equals to whatever the number is there. This is so no student falls behind. For example, at times I don't like to for any of my students to fall behind in my classes. That's why I use different approaches and different notations until they understand. Okay, now here's the 3-step in action. Okay. So I'm at the matrix. So this is going to be my answer. Okay, now this is step 1. Row 1, row 2, and row 3. So step 1, right? This is the 2 is gonna. Step 1, the 2 is gonna be a 0. Okay, again, step 1, I'm going to use row 1. So the 2 is gonna be a 0. And the 3 is going to be a 0. That's why I put them in blue. So now I have to use row 1, right? So here I'm going to multiply -2 times row 1 and add it to row 2, right? Because -2 times 1 will give me -2. Then when I add it to 2, they'll be eliminated. In a similar fashion, multiply -3 times row 1 and add it to row 3. And here's my work. -2 row 1 equals to -2, right? Times row 1 is 1, -3, 2, 0, and there it is. So all I do is distribute the -2. So we get -2, 6, -4, and 0. Then we add it to row 2. So row 2, we just bring it over, which is 2, -2, 1, 3, right? There it is. So then, right, we add them, so we get 0, 4, -3, and 3. So this becomes my new row 2. You see, there it is, right? Row 2, these have to be zeros. So I have a 0 there. So now I do the operation, right, on the bottom for row 3. So -3 row 1 is equal to -3, right, times row 1, which will give us -3, 9, -6, and 0. We can add it to row 3. Right, we just bring row 3 down, and then we add them. We get 0, 10, -7, 7. So that becomes my new row 3. Okay. Now, on my next on my next slide, I'm just going to carry this over, okay? Because I did it like this. So if you do get the slides, you can actually put some words here, right, for your better understanding. But I'm going to continue with step 2. Step 2 will be done on the next slide, which will be here in green. Okay. You see, that's what I had. So now step 2, remember, right, the objective now, step 2, I need to make these two zeros. So in other words, the -3 and the 10 must be zeros. We have to use, okay, so step 2, we're going to use row 2. So row 2 stays the same. The -3 must be a 0. So that's going to change. Row 1 is going to change. And the 10 must also be a 0. So it's going to change row 3. So then I'm going to use row 2, okay? So here, guys, I'm going to multiply row 1 times 4. I mean, 3 times row 2, right? 3 times row 2 and 4 times row 1. And like I said, here, guys, I always have some type of order. Because if you notice, when I put second, it means that's the one that's going to change. So I multiply 3 times row 2 and add it to 4 times row 1. And similar, on the bottom, I'm going to multiply -10 times row 2 and 4 times row 3, right? So here's my work here on the bottom. 3 row 2, right? 3 row 2 will be 3 times row 2. There's my row 2, which is 0, 4, -3, 3. So 3 times 0 will give me 0. 3 times 4 will give me 12. 3 times -3 will give me -9. And 3 times 3 will give me 9. And then I also have to multiply 4 times row 1. So multiply 4 times row 1 will be 4 times 1, -3, 2, and 0, right? And I got those from here, from row 1. It's going to give us 4, -12, 8, and 0. After we add them, it's going to give us 4, 0, -1, 9. So this becomes my new row 1. Now, for the second part, I'm going to multiply -10 times row 2 and add it to 4 row 3. -10 times 0 will give me 0. -10 times -3 will give me 30. I mean, -10 times 4 will give me -40. -10 times -3 will give me 30. And -10 times 3 will give me -30. Then I'm going to add 4 times row 3 will give me 0, 40, -28, and 28. So after I execute the operation there, I get 0, 0, 2, -2. Because remember, guys, that I told you to simplify if possible, so here we can simplify right here. Right? So we're going to divide everything by 2. So we get 0, 0, 2, -2, right? Because 0 divided by 2 is 0. 0 divided by 2 is 0. 2 divided by 2 is 1. And -2 divided by 2 is -1. So this becomes my new row 3. Okay, now I'm going to continue on the next slide and finish off with the last step. But I'm going to carry all this, I mean the step 1 and step 2, to the next slide. Okay, there it is. So now we're up to the last step. So for the last step, we're going to use row 3. So row 3 is the same. The -3 must be a 0, and the -1 must be zeros. So that means that row 1 is going to change. And the -3 must be a 0, right? Because we want to make these two zeros here on top. So the row 2 is going to change. And now we're going to use row 3. So it's going to be, if I add row 3 plus row 1, right? They'll give me a 0 there. So row 3 plus row 1. And here, guys, if I multiply 3 times row 3 and add it to row 2, it'll guarantee that that becomes a 0 there on the slot of where the -3 is. And here's my work. Right, so if we add row 3 plus row 1, 4, 0, 0, 8, right? And can we simplify? Sure we can. So we divide everything by 4. We get 1, 0, 0, 2. That means that will guarantee you that you only use 3 matrices. So that becomes my new row 1. Now for the second row, we multiply 3 row 3 plus row 2. So 3 times 0 will give me 0, 0, 1, and -3. I'm sorry, 3 and -3. And then row 2 just comes down. Right, this is row 2 here, 0, 4, -3, 3. We add them, gives me 0, 4, 0, 0, 0. Right, remember we want a 1 here. in the slot there, so we divide everything by 4. And that's my new row 2. If you notice, you see it matches. You see this is the left side, and this is x equals 2, y equals 0, and z equals -1. So those are my solutions. Okay. Now, I'm going to do one real quick, right? This is how I show my students in class, and also I'd like to show also my PowerPoint with them when I'm teaching this course here. So this is for step 1, step 2, and step 3. All right, so here we go. Step 1, we're gonna use row 1. So row 2's gotta change, and row 3's gotta change. So these two will become zeros, and we have to use row 1. So here I'm gonna multiply -2 times row 1 and add it to row 2. Here I'm gonna just add row 1 plus row 3. Right, and here's my work. Step 1, I call this step 1 A and B. So then here, guys, right? So -2 times row 1 will give us -2, -4, 2, and -12, because I got it from distributing the -2 times 1 will give me -2. -2 times 2 will give me -4. -2 times -1 will give me +2, and -2 times 6 will give me -12. And we add it to row 2. There's your row 2. So we get 0, -5, 5, -10. So here, can we simplify it? Yes, we can, right? Because all these are multiples of, they have a common multiple, which is 5. So we divide everything by -5. It's going to give us 0, 1, -1, 2. That's my new row 2. And again, here, we're going to, for the second part, we're going to add row 1 plus row 3. There's my row 1, and there's my row 3. Once I add them, I get 0, 1, 0, 1. That's my new row 3. Now comes step 2. Step 2, I'm going to use row 2. So row 2 is the same. So the 2 here on top is going to be a 0, so that's going to change. And the one here at the bottom must be a 0, so that's going to change. The row there. Here's my work. So I'm going to use row 2, right? So I'm going to multiply -2 times row 2 and add it to row 1. Then here I'm going to multiply -1 times row 2 and add it to row 3. All right, and here's my work. -2 row 2, I got it from up here, which will give us a 0, -2, 2, and -4. We're going to add it to row 1. There's my row 1, right? I got it from here, the 1, 2, -1, 6. Right, when we add them, we get 1, 0, 1, 2. So that's my new row 1. I'll repeat the process here for row 3. -1 row 2 will give me 0, -1, 1, and -2. Then I'm going to add it to row 3. Row 3 is 0, 1, 0, 1. Right after we add them, we get 0, 0, 1, -1. So that's my new row 3. Now, now step 3, I'm going to use row 3, right? So row 3 is the same. So this -1 must be a 0, and the one on the top must be a 0. So that's going to change, and that's going to change. And here's my work. So to get rid of the one there on top, I multiply -1 times row 3 and add it to row 1. To eliminate this for the -1 is I just add these two. So it's going to be row 3 plus row 2. And again, here's my work. -1 row 3 will give us 0, 0, -1, and 1. We add it to row 1. Row 1 comes from here, the 1, 0, 1, 2. Until we add them, we get 1, 0, 0, 3. So that's my new row 1. And to eliminate the -1, we just add row 3 plus row 2. There's my row 3, and there's my row 2. We just add them. So we get 0, 1, 0, 1. That's my new row 2. So then that's my solution, 3, 1, -1. Okay. And again, guys, I truly believe that if you confuse once your instructor begins to explain this topic, you can always come to this PowerPoint. And again, I will send you the PowerPoint if you wanted the PowerPoint, or you can go back to the recording. My students, when they were taking this course, even 13, 14, I told them to use this recording in the PowerPoint, and they actually figured it out. And they told me that it wasn't that hard. All they did was follow my PowerPoint or the video, and they would pause it, and then they would do the work themselves on the one that we're asking for the assignment, and they were able to get through this. So I have confidence that this will be very helpful for you guys also for your course for 1324. Now, how do you apply it in real life? I believe this is my last slide here. Okay, so here we have something like this is this can be like an actual scenario here. Tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipt was $1,150. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended? I recall when I was taking this course, this was my hardest part of doing this was trying to translate the info. But once I got the concept, now I try to explain it to you guys how I learned it. And again, the solution is you have to come up with 3 equations. And again, it's going to be people with people, right? Because you're talking about people, not seats. So people, I mean, like adults, teenagers, and preteens, right? They're people, and there's 570 people total. And money with money, right? And then this will be the last sentence will be, I mean, the second to last sentence will be equation 3. So let's first start with people with people. So we're going to let x equals to adults, y equals to teenagers, right, in order, and z equals to preteens. There are 570 people, total people. So that'll be x plus y plus z equals to 570. Now comes money with money. So if the adults, right, were 5, so that's going to be $5 for adults. That becomes 5x. And $3 for teens, right? And the teens were y, so that's going to be 3y. And $2 for preteens, right? And preteens are z, so it's going to be 2z. What was the total number of people? I mean, what was the total number of income or receipts? Was 1,950. So it's going to be 5x plus 3y plus 2z equals to 1950. So I got my first 3 equations. So I'm missing a third one. Now this right here, guys, equation 3, right, comes from here. Okay, now this is the correct. This was where I used to have a lot of difficulty when I was a student. Right, so here they're talking about, right, teenagers and preteens. So my teenagers are y and my preteens are z. So it's saying y equals to, this is why it should be y equals to 3/4 z. But how do they come with this? Okay, this way I tell my students, write it how it sounds. You see, for example, right, if it is difficult, write it how it sounds and then flip it. By flip it, maybe I'm using the wrong words there. Okay, but I can change the words later. But I just say we flip it. This is what I mean by flip it. So 3/4 as many teenagers, right? So I'm gonna figure it's gonna be 3/4 y, right? 3/4 y equals to z, right? Isn't that the way it sounds? But then you flip it. You send the 3/4 over here for the z is. You see, or maybe like I said, maybe that the notation flip it. Maybe it's not the right word to say. But maybe next time I can change it once I find out wording that's more easier. And again, the book doesn't show you this way. The book shows you this way that you have to come up with this equals to this, but they don't explain how. So that's why I come up with the whole explanation for the students to be able to understand it. But anyway, right, I need to put it in the form ax plus by plus z equals to c, right? So multiply both sides by 4. Then I'm going to subtract 3z to both sides. So this is the way I want it, right? Because I want it all in this form, like I did it earlier. So this is my new equation 3. You see, guys, now you can do it by matrix, or you can do it by the way I did it. Remember, the plan was when you had 3 equations, do 1 and 2, get rid of the x's. Do 1 and 3, get rid of the x's, and so forth. Now you can do it that way. But this is my solution. I say try it, and these are my solutions. So if you want, you can try it and see if you actually get that right there. But this is the answer. Or you can plug into the calculator also. There's a way that you can plug into the calculator. Okay, and just plug in the matrix and do certain steps, and they'll give you this as the answer. But I recommend for you to actually know exactly the steps, how to work it, because in 1325, you have to know and you have to show a lot of work. So it's always good to know how to do it. And then you can use the calculator to actually help you to make sure that it's correct. Okay, I guess, right, so there's 220 adults, 150 teenagers, and 200 preteens. And I believe, okay, so just disregard this one, guys, okay, this last one, because at times when students had a chance to view the video, they could actually go here and answer these questions, right, to get credit. So just disregard this last slide. Well, guys, I hope you enjoy my PowerPoint. Um, I really take pride with how I explain material, and it's always I always keep my students into consideration, especially the students that haven't been in school in a long time. Those are the students that I always try to reach, the students that are non-traditional. Okay, because I also came back to school when I was 43, so I know how it feels when the student is lost, and at times the instructors they don't want to help because they might say something like the material you should know by now. So go get help with the tutoring centers. Okay, and that's why I always take those students into consideration because I've been there. Okay, so do you guys have any questions?
Is there any questions for Mr. Azasi?
If you want a PowerPoint, send me a text. If you want, I can write my email there on the chat, and I'll send you a copy of this PowerPoint. Okay, so let me see the chat here. Let me put everyone. Let me put here my email.
All right. Well, if there's no more questions, I'd like to invite you to next week's QBEs. On October 29th, we'll be having the mental health of students, faculty, and staff returning on campus, presented by the Mental Health Committee at EPCC. Also, for Happy Math Hour, for Math 1314, we'll be going over the properties of logarithms, exponential, and logarithmic equations. And then for Math 1324, we'll be working with matrices again. We'll be doing basic matrix operations and inverses. Thank you all for coming, and I hope you have a wonderful weekend.